Tech stack is, again, like I say, it's not rocket science because anyone can even put together a custom script that they write that does the various parts of the pipeline
Mm-hmm.
and the platform. So the real value that we bring to our customers is really not the tech stack. It's how we get the machine to understand the data and process it at scale for the customer. That's the real value of it, the platform.
Hello, everybody. Welcome back to another episode of our Asset Intelligence series. I'm Deborah from Human Managed, and today we have Jesum, our chief engineer, with us again to talk about his work on the Asset Intelligence product. So, hi Jisung. I brought you in today to talk about our new product, Asset Intelligence, that we have launched on Microsoft Marketplace and we will be launching on AWS Marketplace as well. Based on our product description, specifically on Microsoft Marketplace, we position Asset Intelligence as a product that and I quote, continuously collects and enriches enterprise data, creating a live context engine. So, from your perspective, talk to us about what it means when we say asset intelligence enriches enterprise data and what context engine are we creating?
So there's a couple of things in that statement that's important. The first one is context, and then the second one is enrichment. And let me go through these two one by one. So when we talk about context, the challenge that we always have with any kind of enterprise when we're talking about whether it's establishing asset intelligence or trying to figure out what some security alert is or what a metric or a number means for for that enterprise. The challenge is always trying to establish context, and context really just means you know the environment enough to be able to answer those questions in a meaningful way, right? So, a classic example is if I just show you a computer name called 123456, without context, that just tells you it's a computer name. But with context, you then get into the second part of that statement, which I said, the, which is enrichment. So, with context, you get enrichment, or maybe the other way around. With enrichment, you get context. Yeah. So, if you are shown a host name that says 123456, if you have enrichment, and you can then establish context, which tells you this machine is run by which user. Maybe it's the HR director. And then you can also establish context like what operating system is it running? What is it normally used for? What time does the user log on? What applications are installed? A whole host of telemetry data becomes available to you. And when you take all these and you combine it together into an asset object, you can then establish a very rich story that you can tell about the journey of that asset through time in that customer's environment. This is particularly important because without context, it's like you going to a doctor and just saying, "Doctor, I have a stomach ache," and then the doctor immediately gives you medication for it, which may or may not work. So, in any kind of processing that we do for our customers on our platform, we always make it a very important criteria for us to be able to establish context for the customer.
And how does the asset intelligence product establish this context?
So, asset intelligence is just one part of the context for the customer. Going back to the example of the host name with all the enriched data that goes into it, that's just one object. Now, obviously, we have, anytime you have an object, you usually will have two other things that go along with it. You have a predicate that goes along with it, and you have a subject that goes along with it. The subject could be John, the predicate could be administrator. So John is the administrator for that host name. Or it could be Lila, user. So Lila is the user for that computer. So by being able to do a subject predicate object relationship across multiple data sources, or bringing all those data sources back to build that SPO story, we can actually enable the platform to answer a lot of questions that the enterprise will have about that machine at any particular point in time. And believe me, that a lot of folks who do work that's related to IT, work that's related to cybersecurity, work that's related to anything that touches machines, that particular machine, they would love to be able to get that kind of context at their fingertips. Because I know one thing for sure is this. If you ever get a alert that says some malware was detected at that machine, what do you do as an internal IT security person working in SOC, right? You will always have to spend hours and hours doing triage. You have to go through 20 different data
Yeah.
sources, 15 different people that you have to talk to, 7 different set of logs. You have to go look at that machine itself, pull out all the information before you can finally form that story. So asset intelligence is one part of that puzzle that helps you build one part of that story. It's certainly not the only one. There's a lot of other components that come together to build that story.
Okay, so now that we have more information slash context about what asset intelligence does, moving to the more technical side of things. In terms of the technical specs or the technical processes that go on behind the scenes of asset intelligence, right? How walk us through the flow of how it collects
Oh,
data.
so we have what we call the collect and receive microservice. And these use two different technologies. One is this technology called Airbyte, which is the collect microservice. And then we have another one called Vector, which is a tool produced by Datadog, which is the receive microservice. Now that those two components are responsible for interfacing with the external systems on the customer side to pull the data in. Once the data comes in, it then goes through a series of steps where we transform the data, we normalize it, and we store it into durable object storage. That's typically in the cloud. So, for example, an S3 bucket. Uh, and as that object travels through the pipeline, we take snapshots of it at various stages. So when it first comes in, it's raw, we save a copy. When we normalize it, we save a copy. When we do context calculations on it and we add features into it, we save another copy. And so there is a traceable stream that you can see as the asset moves through the pipeline. Right at the end is where we have a bunch of processes that we run. And again, depending on whether the data is being processed in real time or whether it's processed in batch. And if it's batch, we use this tool called Dagster. And if it's processed in real time, we use this other tool called Warpstream and Bytewax. Once that data has gone through that final processing, it then lands into durable object storage again, and then it gets ingested into our lakehouse. When it is in the lakehouse, it is then ready to be served to the customer. Now, this entire process, if it's done in real time, typically takes about 2 to 3 minutes. If it doesn't involve any AI models, it's usually done in under 1 minute. On average, probably about 30 to 40 seconds, it's done. If it's done in batch, then of course that will depend on the batch schedule. Maybe every 15 minutes, maybe every hour, or maybe it's triggered whenever data arrives, etc. So the final output lands in the lakehouse, then that gets served to the customer either in the form of some kind of communication that we push to the customer, or we serve it into our front end application, the web application, where customers can log in and consume it. So that's not the end of the journey, of course, but that's just the beginning of our touch point with the customer as far as the output from the platform is concerned.
I guess this gives a summary of the flow of things on like in the technical side, like how collects data into which tool, and then so on and so forth. Am very familiar with the web app, and I'm very familiar with the product and what it actually does, etc. But learning about the technical side is actually very interesting because it's there's a lot that goes on.
Yes.
You see the web app and you see like maybe the email or something, but the customer, you don't think about what goes on behind the scenes in order for all this to be presented on the web app accurately.
The customer shouldn't need to worry about that because they trust us to do that work for them. And I think at some point, some customers will have those questions like, I'm seeing the output now. How can I trust the output?
Yeah.
So that's where the pipeline that I alluded to previously about where as a piece of data moves through every step in the pipeline, we take a snapshot. That helps us build that story to tell the customer, okay, look, the output came out like that. It's green instead of red because of the journey that the data has taken through the pipeline. That I believe also helps build trust with the customer. And if ever there is any point in time where the customer looks at the output and says, wait, something's not right, then we can trace it back and look at it and figure out what went wrong. Like maybe a calculation was wrong, maybe a model was wrong, or maybe we didn't have the right set of data, so we had to extrapolate or assume. And then we can go back to the customer and say, yeah, you know what, maybe we'll tweak this number, or I need this additional data source from you that I can then insert back into the pipeline, and then you will get meaningful results. So that I think is one of the reasons why the company is called human managed, because
Mm.
it's not just the machine that's doing the work, the human is still in the loop. And I think that's one very key point about how we conduct our work with our customers. We always keep the human in the loop.
I guess that's something that we also take pride in because we place a lot
Well,
of importance on the value of like human enrichment, right? And we see the
yes,
value in having
correct.
humans involved in the
Well,
processes and stuff.
I would just add one more thing. I think that the tools and the technologies that we have should amplify human capabilities, not
Mm-hmm.
replace human capability. Think of it that way, then yeah, it makes a lot of sense because there's stuff that humans do better than machines even today. But there's stuff that we do really poor, which machines do really well. And so we should get the best of both worlds when we combine them together.
I like that perspective. I agree with your
Thank you.
point of view on that. So I guess back to the technical stuff. With so many moving parts and so many tools, I'm sure 99% sure that there were many iterations of this. And there were many versions and changes and revisions. So how does the earliest version of asset intelligence compare to what we are launching today?
Hot Wheels. You know Hot
Yeah.
Wheels? Those little plastic, sometimes metal toys
Yes, Hot Wheels.
made in Malaysia, made in China, made in Vietnam, whatever, right? That was like version one. And right now, what we have is a proper car that you can drive. And of course, that's not the end. The goal is to eventually get to a point where it looks like a self driving car, a Tesla,
Like
for
a
example.
Waymo?
Yeah, like a Waymo or a Tesla that can make decisions on your behalf. So in that sense, then the car becomes a tool that makes you more productive because you don't have to worry about, wait, I'm trying to get to from A to B. I need to plan out in my mind. Before GPS was around, everybody had to go into the car, sit down and think for a
Read the
few
map in the
seconds,
book.
like, yeah, which route am I going to take, this way, that way,
Mm-hmm.
that? Okay, then you start driving, right? And then GPS came about and then you start looking at the screen. And then eventually now you have self-driving cars where the maps all built in. So that's what I mean by amplifying human capabilities. It makes us more productive because we don't have to worry about these things that the machine can do quicker for us and more accurately for us. So version one of Asset Intel was kind of like that, like the Hot Wheels. It looked like a car, probably had the sort of feel of a car, but you couldn't really use it like a car. You only used it like a toy. So it was good for us to experiment, good for us to learn from. But we saw a lot of problems and we quickly knew, actually, even without a lot of experimentation, we already knew where the gaps were. That was version one. And of course, through the different versions, we went through a lot of iterations. We took a lot of the learnings and we made a lot of strides. And it's gotten to a point now that as things mature, squeezing out that extra 10% gain or 15% gain becomes a little bit more challenging. And so we know that's good because that means we are starting to reach a point where we are finally happy with the output of what asset intelligence looks like.
Mm. So I'm just curious, since you mentioned that you identified gaps and in fact, it was quite obvious from the start. What were some of the biggest challenges that you faced when building
Oh,
this product? And
yeah.
how did you overcome them?
Um, what I said earlier about the tech stack is still true when I answer this question. The tech stack itself is not rocket science.
Mm-hmm.
And if you look across how some of the other companies out there would approach this problem, you probably get to like 70-80% of a similar design, right? The biggest challenge for us was the data itself. And what I mean by that was it's a combination of getting the right data source and then formatting the data in a correct way so that the data is almost explains itself. You don't, and I'll give you a very simple example, which anyone who works with databases will understand. You don't call a field name A, you call a field name username. So you know that username means a username is going to be in there. And you keep it that way so that when you send that piece of data together with all this metadata that goes along with it to a model, the model is able to infer accurately what pieces of data go in where. And this extends just beyond the field name, of course. There's also other metadata that we tag along. So there's like the name of the data source. We have standardized fields for date timestamps. We have other metadata that describe when the data arrives, when it gets processed, when it's gone through transformation, etc., etc. So that schema of that data, that format, I think we did like probably like 30 over iterations of that.
Wow,
Yeah,
that's a lot.
I think about there, about 30 over iterations just to get it right. Even then, even today, it's still not perfect. There's still stuff you can tweak to make it better. But we don't want to overfit something where the model then starts giving answers that are a little too narrow,
Mm.
if that makes sense. But yeah, the biggest problem for us was the data itself, describing the data in a way that we can get the machine to understand it.
Describing the data in a way that you can get. That's interesting because I think a lot of people with AI and stuff, they think that the computer can just understand what you're saying really easily, which I have found to not be true personally.
That's quite correct because computer is nothing more than a machine that just calculates ones and zeros. Literally ones and zeros. That's all it's doing. What you see on the screen with all the graphics and all the pictures and all the text, the machine doesn't understand it. It's just doing ones and zeros. The models that we see today is just a very specific solution to a problem which we've had for a very long time, which is getting the machine to be able to,
Predict.
yeah, statistically process language. That's all it's doing. Does it understand the language? No. So the way we understand something versus the way a machine understands something is fundamentally different. It's just that the output from the machine looks like a pretty good proxy to how we understand things. But again, you can break the machine very quickly with some targeted questions, which you know a 5-year-old will be able to answer just like that, but a machine will struggle to do it.
Apparently, like ChatGPT can't solve Singapore like primary school math questions
There you go.
because we are the only country that uses the model method, and
Yes.
they don't. ChatGPT doesn't know the model method.
Because it's not been trained on that model.
Then I saw somebody describe ChatGPT and other LLMs as like autofill on steroids.
So think of it this way, right? If you show someone a balloon and they've never seen a balloon before in their life,
Right.
right? And assume this person is like a 20-year-old, fully formed brain, neurons, all there connected, everything's fine. They look at a balloon, they probably only need to see a balloon twice
Right.
and they'll know it.
Mm-hmm.
You need to show a machine a balloon maybe 1,000 times for it to learn it through reinforcement learning to recognize balloons when you show it to it again. That's the difference. A human gets it once, twice. A machine takes 1,000 times to figure it out. Well, it's not even figuring it out, it's just statistically reinforcing those parameters to be able to understand or recognize a shape that looks like a balloon.
So you had to reinforce to the S intelligence model
Yeah,
many,
correct.
many, many, many times.
Correct. Correct. So AI today is not really intelligence, it's just very good pattern recognition. And that's
So
good enough for us for now.
for asset intelligence, you mentioned pattern recognition, right? For asset intelligence, when we are talking about assets, in my previous conversation with Karen, she mentioned it can be any type of asset. It can be like logs, inventory, I mean, whatever, right? So how do you train a model to do pattern recognition on so many different mediums of assets?
The data, how we describe the data is the key to it. So if you can put enough metadata into the data, the machine will get it with very little supervision. There will be edge cases where you will have to tweak the prompt or you will have to tweak the model with additional reinforcement learning for it to understand it. But by and large, I think about easily more than 90% of the data that we throw at it is something that the machine can immediately understand what it is. For most enterprises, there are already some low hanging fruits.
Mm-hmm.
Computer names, server
Yeah.
names, network equipment, IP addresses,
Yep.
users, blah, blah, blah. There's a whole catalog of that. And just addressing that, those low hanging fruits, is already such a huge win for the customer that the edge cases is something that isn't something that will immediately become a pressing need for the customer. And if you take this principle and you go across the board to all enterprises in any industry, you will find there are common definitions of assets. So you typically start with that first because that allows us to have a meaningful starting conversation with the customer.
That is so interesting because getting to talk to you who built the product and then understanding more of the processes and what you know, not to be dramatic, but kind of the journey of building and reiterating and all the different revisions. I think it's quite insightful because I myself have not built a product like that. I don't think I probably might not ever. So hearing about it is like, oh, like this is new to me, and I think anybody watching this can also get a glimpse into how we do things here at Human Manage, not just seeing our final product, but also getting to know like the people and our build philosophy and just like our the way we do things, you know, what guides us when we do certain things. Because I feel like the end product could be made by anybody,
Mm-hmm.
but how you got there is like unique to you.
That's true. It is true indeed.
Yeah, and then you said like the tech stack is not rocket science. So if it's not rocket science, then anybody else can use that tech stack. But not, I mean, as
I
far
mean,
as I'm concerned, like nobody's done that.
correct. The tech stack is, again, like I say, it's not rocket science because anyone can even put together a custom script that they write that does the various parts of the pipeline
Mm-hmm.
and the platform. So the real value that we bring to our customers is really not the tech stack. It's how we get the machine to understand the data and process it at scale for the customer. That's the real value of it, the platform.
Okay. I think that kind of wraps up the questions I wanted to ask, and it's a good way to end it by uh, reiterating what value we bring to the customer.
Okay.
Because I think focusing on a product, you know, beyond that is like, okay, you have this web app, you have this service, but what else? Like, what's the real value add that you're bringing, other than just like, oh, I have this like app, and then you can,
Correct. Anybody can write a web app.
yeah,
Correct.
especially with cloud code
Yeah, and
or
with vibe
whatever it
coding, you
is.
can absolutely do that. Correct. And maybe this is a small analogy that anyone can vibe code, but you will see a difference when you put a software engineer and a regular Joe in front of Claude and ask both of them to write code.
The
through
regular
vibe
Joe
coding.
being me. I'm the regular Joe.
The output looks the same,
Yeah,
right? You get the app,
yeah.
but the structure of the app, whether it's scalable, whether it's secure, whether the code is future maintainable by another AI model, there will be a stark difference between the regular Joe and the software engineer. So
Well said.
yeah, that's
We
what it
still need
is.
software engineers, guys.
You still need brain.
We still need brains.
Yeah, you still need a brain. You cannot outsource your brain to a machine. It's at least it's not possible yet today. I don't know, maybe in 10 years time it might be, but it's not possible right now.
Okay. Thanks for chatting with me. I really enjoyed our conversation and I learned a lot. So thank you very much for watching this episode of our Asset Intelligence series. I hope you guys enjoyed it. If you watched all the way to here, like and subscribe. We post almost every week.
Thank you.
And we will have Jesum again because
Yep.
he's so fun. So yeah, thanks for watching. Bye.
Bye.